All right, so we'll go ahead and get started. Hello, everyone. My name's Alex, and I'm the team captain of Roboctopi. Today, we'll be sharing with you guys how to incorporate pulley belts into your robot design. And I'll be presenting alongside Nico, Logan, and Lauren. Next slide. So we'll start off by asking ourselves, why belts? Why belts over chains? First of all, belts are really easy to maintain. You don't have to oil them or check them nearly as often as you'd have to check chains. They're self-aligning, so if any of the pulley wheels are slightly misaligned, the belts will not easily fall off, and they will also try to align the pulley belts themselves. And this is very different from chains because chains will fall off really easily if your pulley wheels are misaligned, which probably you guys have experienced. Belts have no backlash, so as soon as one of the pulley wheels starts turning, the other one will start turning immediately after that, because the belt, if properly tensioned, will transfer all of the torque from one wheel to the other. And they also transfer a lot of torque, so they're really good for any mechanism that needs really high torque transfers. And then some of the advantages of chains are that they're easy to maintain, or they're easy to change, not maintain. Uh, uh, you can tension them really easily by changing their length, by pulling out some of the linkages. But they're really hard to maintain because you have to oil them and make sure no dust gets in there. And also you have to make sure that the pulley wheels are perfectly aligned. And they have quite a bit of backlash when compared to belts. So that'll lead to some inaccuracies if you're trying to get a really accurate system working. And they'll fall off pretty easily if your pulley wheels are misaligned and you don't do the proper maintenance on that. Next. I'll be handing it off to Logan to show you guys some of the math now.
Hi, I'm Logan. I'm the autonomous programmer for 14496 Roboctopi. So today I'm going to be showing you the math behind an arbitrary pulley. So this is good to know, but not required, because you'll primarily be working with toothed belts, which are ordered in specific lengths. It's for an arbitrary belt rather than toothed, so which are sometimes used in FTC conveyor belts. The math formula might look complex, but is actually pretty simple to compute. And this is an approximation, meaning you won't get a perfect length. However, this is fine because belts will stretch slightly over time and fit to those inaccuracies, and you'll have tension anyway. So this is the formula. It has three variables: the center distance, the pitch diameter 1, the pitch diameter 2. So the formula is 2 times the center distance plus pi times the first pitch diameter plus the second pitch diameter over 2 plus the first pitch diameter minus the second pitch diameter squared, all over 4 times the center distance. So an example of the computation here would be, here you have a belt and the first pitch diameter is 4, whatever unit you want. The second pitch diameter is 7, and the distance is 10. So first you'd compute 2 times c, which is 2 times 10, plus then plus pi times 4 plus 7, or pitch diameter 1 plus pitch diameter 2, which is 4 plus 7, which is equal to 11 over 2. And then plus 4 minus 7, which is -3 squared, which is 9 over 40. And when you add all those up, you get 37.5. Now how to make a pulley wheel in CAD.
Okay, hi, I'm Lauren, and I'm going to show you guys how to make a pulley wheel in SCAD. So many manufacturers already sell standard pulley wheels, but we'll show you this just in case you need it or you can't find what you need from a manufacturer. None of this information is new. All of it comes from this Instructable, which we'll link in chat. So all of the links that I will be talking about in this will also be in that link. Okay, I can link it right now.
I got the links.
Oh, Alex got it. Okay. Next slide, please. Thank you. So first, you'll need to go to the OpenSCAD website and download the program, which is just under downloads. So the difference between OpenSCAD and a traditional CAD approach is that OpenSCAD is a script-only like modeler, while CAD is where you directly manipulate the visual model. we'll be using this profile that we make in SCAD in CAD later, which Nico will show you. So after you've downloaded the OpenSCAD program, you have to download the parametric pulley DXF file from either the Instructable or the Thingiverse link, which is also going to be linked in chat. And after you've downloaded both the program and the DXF file, you open it in the program, and this screen is what should pop up. On the side is the code which we will be modifying. So the only three things you need to modify in the code are these three lines, which is the number of teeth, the shaft diameter, and the profile, which all of the instructions are commented on the side. Oh, wait, before we move on, it's important to note that you have the correct pulley with the correct type of belt, or else it will not work.
We'll
These
explain a little more about the difference between different belts later on.
These are our recommended settings for FTC, which is 24 teeth, 6mm shaft diameter, and an HDD5. So to render all of this, you just need to press F6 or the button that I've circled there, and that should pop up, what we have on screen. And once you're satisfied with your render, just export it as a DXF, and Nico will show you how to use this profile in CAD.
Hi, I'm Nico, and I will show you how to design a pulley wheel in CAD using the DXF file we just created. So we're going to use this DXF file, and we're going to turn this into this CAD file that you can either 3D print or manufacture in some other way. So first what you're going to do is open the imported DXF file in your CAD software, and then you're going to extrude the sketch profile by whatever belt thickness you have, plus about 1mm, so there's a little bit of play. And in this case, we're using a 9mm wide belt, therefore it's going to be 9 + 1, which is 10, so 10mm. Then we're going to create a sketch on the top plane, and this will allow us to create a guide on the side. So we're going to create a circle that has a diameter of whatever the pitch diameter of your pulley belt is, plus the diameter of the actual tooth. So in this case, it's 38 + 3, which is 41. And then you're going to extrude this profile by 2mm, and that will create a guide on the side so that if when your pulley belt is turning, the pulley doesn't slide off the side of the pulley wheel. Next, we're going to do the same thing, but on the other side to create another guide. But this step is a little different. So you're going to create another circle, same diameter as before, and then you're going to finish the sketch. But when you go to extrude, you're going to select your two profiles and then extrude it again by 2mm. But this time you want to make sure this selection here is not join, but instead on new body. And this will create two separate bodies instead of joining the two together. And this will allow you to 3D print this without any overhangs and supports. And this will also allow you to slide this panel off, slide your belt on, and put the panel back on without having to take your pulley wheel off your axle. Then we're going to add small pins and indents on each part. So pins on one side and indents on the other side. This way, when you assemble this, they'll lock together nicely. And we'll also add small chamfers on the inside of the guides. We recommend about 1mm, and this will make sure it's not such a hard edge. Next, we can sketch and extrude any hole pattern on one side of the pulley, and then you just extrude that right through the entire thing. And you can design whatever needs to fit for your design. So depending on what hub you use and how you want to attach it to your axle or any other method you want to use to attach this to your robot, you can just design whatever pattern you need right here. Just make sure it doesn't interfere with the little pins that we created in the last step. So here's the final product. I've added a couple components like a hub, an axle, and a couple screws to demonstrate how this could be assembled. So the screws mount through the two pieces that would be 3D printed and into the hub. This sandwiches the two pieces together and make sure they're solidly mounted. And then you can mount the hub onto any axle and mount that to your robot. Now we'll show you how to find the right belt you need using CAD once you have a few pulley wheels in your design. So to do this, you're going to use the measuring tool in your CAD software, and you're just going to select 2 of the circles on your pulley wheels. This will automatically compute the distance between them right here, and in this case, it will be 120 millimeters. So once you know this distance, you can also take note of how many teeth are on each pulley wheel, and once you have all of that information, you can input that into SDPSI. Alex will show you how to do this and find the right belt that you need.
Okay. I'll be showing you guys the SDPSI website and how you're going to find the belts you need on that website. The SDPSI is an online store we use to find SDPSI is an online store for drive belts, pulleys, and other products. We use their center distance design tool because it's a really good tool that'll give you the right belt you need for your application and your center distance and pulley wheels that you need. We recommend using metric belts because metric is superior, and use HTD or GT2 5 millimeters for high torque applications, or use HTD 3 millimeters or GT2 3 millimeters for low torque, higher speed applications. HTD generally has more options for stock belt lengths than GT2 because it's an older and more widespread profile than the GT2, which is basically an updated version of the HTD. We want to remind you guys also that we have no affiliation with SDPSI, and we're not endorsing them. Their online center distance design tool was chosen for its ease of use and parts availability. So now we'll go to the website that they have. And then I'll link, Nico, do you want to link it in the chat?
Sure.
So we'll start off by selecting metric up here, because that's what we use mostly. Actually, not mostly. We use that all the time. And then we'll select HTD 5 millimeters here. This is the 5 millimeters is the distance between the teeth on the pulley wheel and belt. And now we'll go over to the number of grooves on the pulley wheel. Here we'll select 24. We recommend 24 teeth or higher. This will give you a good ratio between the friction and the amount of torque it can transfer. If you have less, you'll probably end up transferring less torque, or you'll end up breaking a tooth possibly as well. And then also, this is the second pulley wheel. Do not select, if you're buying your pulley wheels on the website, do not select any of these with the asterisks on them, because they will be very expensive because they're gonna have to change the tools that they use and make them custom for you. So they'll cost you an arm and a leg. But if you're 3D printing them and using the CAD that we showed you earlier, you can absolutely select these and just 3D print them yourself. And then we'll go up here and select our desired center distance. We'll go with 200. It's a good number for now. And then down here, it shows that it changed the number of teeth for the belt to match the desired center distance that you inputted. So the desired and actual distance differ because of several factors in here. The number of teeth on the pulley wheel will change the center distance. So let's say I change it to 105. This will increase the actual center distance between the two wheels to 202.5. This is because the distance between the teeth is 5 millimeters, and each belt will increase in size or decrease in size by 2.5 millimeters for this particular HTD profile. And if it's the same, if I lower this to, let's say, 103, then it goes down by 2.5 millimeters. So these two, you want to be either exactly the same, or you want this to be 199. So 1 millimeter less than your desired distance is good. That'll give you a pretty well-tensioned belt. But anything over that or under the 1 millimeter threshold, you will have either too loose of a belt or too tight of a belt. So if you can't find a belt that is not going to be very expensive like the ones with an asterisk here. That fits your desired center distance. You're going to want to either change your design or change the number of teeth on the pulley wheel, which is another factor that plays into this. So let's say I change this to 25. This will decrease the center distance because this pulley wheel will have to be a tiny bit bigger. So your belt is going to have to move in a little closer to accommodate for that. Those are kind of the two main factors that play into the center distance. And then up here is the ratio that you have between the two pulley wheels. Right now it's 1 because we have the same number of teeth. But if I change it again, it's not changed as well. There we go. So now the actual ratio is different. And then this desired ratio is what you want the ratio to be. So let's say you want a 2 ratio, then you just change this to 48. Change this back. Now you have a ratio of 2. And since you want the ratio to be 2, these two match. That back. And yeah, I already explained about the asterisks. So and then when you're ready to order your belt, change this to 24. So when these two match right here and these match as well, and you have all the stuff that you want right here, then you just click show parts and it'll show you different belts that you can use. And if you're going to order your metal pulleys, not 3D print them, then you also click here as well and click show parts here, and it'll bring you to this link here. So here it picks 5mm HCD pitch, which is what you selected up here, 104 teeth, which is what will match your actual distance to your desired distance. And then this is, it shows different widths of the belt. We recommend using 9mm. We found that that's the right amount for the torque and speed we need in FTC for most applications. But if you need maybe higher speed, lower torque, you use 6mm, or higher torque, lower speed, 15mm, and make sure you get the right pulley belts for that, and pulley wheels. And then they also come with single-sided or double-sided neoprene belts, and the double-sided has teeth on both sides. Single-sided has teeth only on one side. So for different applications, you might need teeth on the outside as well. And then once you're ready to order, you just click on that link, and it'll bring you to the SDPSI website where you can order your belts with different ranges of price, or you can go to any other parts manufacturer that has the right profile and links. And that's all for what I have for SDPSI. Nico, you want to share again?
Wyatt has his hand up.
Yeah, we have a question.
Go ahead.
I wanted to ask, do we have to buy what we make?
What do you mean?
Do we have to buy it?
Buy the pulley wheels or pulley belts?
The belts.
Yes, you can't make belts. You would have to buy the belts, but you can, if you have a 3D printer, you can make the pulley wheels as Lauren and Nico showed you.
But we don't have to do it.
You don't have to incorporate belts into your design, but if you want to incorporate belts into your design, you will have to buy the right belt for your application.
But do we have to buy the pulleys though?
You don't have to buy the pulley wheels if you can 3D print them and design them.
Okay.
Any other questions so far? All right, Lauren, go ahead.
All right, okay. So I will be showing you how to tension belts. The tension on a belt is very important because it affects the overall function. When you have too much tension, the system will stop working because of the immense amount of friction. And if you don't have enough tension, it will skip and you may break a tooth on the belt. So, to know when you have tensioned the belt correctly, it should feel sort of firm and tension, but yet squishable, like the pictures we have on the side. As you can see, we can still squish it a little bit, but that's a substantial amount to tell us that we have tensioned it correctly. And if your belt is skipping, you either need to tension your belt or you're using the wrong type of belt for your application. Specifically, if an HED5 or a GT2 is skipping, it's recommended that you use a wider belt or to increase the size of the pulleys, because if you're transferring a lot of torque on a smaller wheel, you'll break your teeth, which is why we recommend a 24-tooth pulley wheel. So there are numerous ways you can tension belts. We've listed a few here. The first one is using sliding tensioners, which is where you put one wheel on a sliding mount and adjust. It's essentially where you slide the pulley shaft along a groove to adjust the tension. It can be up or down or left or right, like the two photos we put on the top. The second system is the eccentric tensioning system, where the pulley wheel is on a shaft that can be rotated around a center to adjust the tension because it increases or decreases the distance between the pulley wheels. It's similar to the sliding one, except of like instead of sliding, you rotate it. And the photos in the bottom as well. The third method is to use an internal tensioner, where you have a wheel that slides perpendicular to the path of the belt on the inside. And since it's on the inside of the path of the belt, it requires like a toothed wheel to interface with the tooth surface of the belt. And it should look like what we have on the top right. The fourth way of tensioning a belt is to use an external tensioner, which is very similar to an internal one, except the wheel or bearing is mounted on the outside of the belt and moves to tension the belt. There are other ways you can tension it by using bigger wheels or moving the entire shaft to either loosen or tighten the tension, but these are the ways that are most common. And that's it.
All right, so now I'll be telling you guys different types of belts that we've kind of gone over a little bit during the presentation, and how to read the labeling system that they print on the belts. So in case you need to like order a belt that you already have to add another one onto your robot or something like that. So there's two different main types of belts that we'll focus on, the HTD and the GT2. These are the ones that you'll mainly use for FTC. HTD stands for high torque drive, and this will transfer quite a bit of torque, a lot more than chains, as I mentioned earlier. HTD5 means that there are 5 millimeters between the teeth, and therefore the belts will come in 2.5 millimeter increments, which this will play into your center distance that I showed you earlier. And make sure, this is really important, make sure you use an HTD pulley wheel profile with an HTD belt. If you don't do that, the system will fail immediately, and you'll have to reprint or reorder your pulley wheels or belts. And then GT2, it's a new standard. It's an update to the HTD standard. They're mostly the same, except the GT2s handle slightly higher torques and have less vibration, but it often comes in less sizes, and there are fewer suppliers since it is a newer standard. HTD works just fine for FTC. That's what we use because it has more suppliers and it's often a little cheaper. And the GT2 standard has these more trapezoidal teeth, which is why it has a slightly higher torque and less vibrations. GT2.5 means the same, means that there are 5 millimeters between the teeth, just the same as HTD, and therefore the belts will come in 2.5 millimeter increments. There's also 3 millimeters for both GT2 and HTD. So those will come in 1.5 millimeter increments and have 3 millimeters between the teeth. And again, make sure you use the GT2 pulley wheel profile with the GT2 belt. And finally, we'll show you guys how to read what is printed on belts. You'll often notice that numbers and letters like what are printed on that belt right there to the right will show up on any belts that you might have. So I'll start off by saying that the SDP is the manufacturer. There you go, yeah. And then the number to the right of that is the part number. And then up on the top image, you have HTD, which shows you the profile. And then you have 5 millimeters, which is the distance between teeth. And then 70 is the number of teeth on the belt. Then to the right is another part number as well. If you can't identify any writing on the belt that you have, or and you want to really analyze it, because that'll show you the tooth profile and tooth spacing. So you can kind of measure that and figure out what belt it is if you need to order a new belt for one that broke, or you want to add another belt similar to the one that you already have on your robot. And remember, HTDs have rounder teeth and GT2s have more trapezoidal teeth. So that'll come into play when you analyze it to try to understand which belt it is. And I have one more thing, actually. Takes about 2 weeks for belts to arrive. So something I forgot to mention earlier when I was presenting the SDPSI. That's mostly what we've had waiting for belts, about 2-week delay. Next slide. Any questions?
Yes. So you said that it takes about 2 weeks for the belts to arrive. Where the SDP company, where are they? American company? Are they foreign?
I believe they are American. I don't know where in America they are from, though.
Okay.
I
Just
can
wanted to
find that out.
yeah. Kind of maybe like I just wanted to know where they were coming from.
A good question.
I'm pretty sure you can also pay for like faster shipping if you want to. I'm not sure on that though.
I think some of it also has to do with like belts that are in stock versus ones that aren't.
Yeah, the
So-
ones with the asterisks will also probably take maybe a month because they'll have to retool their tools and make them custom for you, in addition to being more expensive.
I think they show like when you order if the belts are in stock or if they're waiting, like they'll give a lead time on belts. So if you're ordering a lot of belts in like lots of different sizes, sometimes you'll find that one or more of those belts are not in stock, and they'll be in stock in 1 week or something.
Google says they're from New York.
Good question. How do you like the software, the OpenSCAD?
So for the OpenSCAD software, it's mostly just a one and done thing. So you go on there and then make a lot of different pulleys and just import them into Fusion or whatever CAD software you use, and then make your pulley wheels. And then then you have them there, right? You don't need to do that again. But we like the software. It's really easy to use. Just go in there and export, put in a couple numbers and export it.
So you use it primarily for the poly then, I guess, because you mentioned you incorporate that to Fusion.
So
Yeah, you use it. Oh,
go
sorry.
ahead, go ahead.
Yeah, use it just for the pulleys, and then you can import it into the Fusion that Nico was talking about.
Thank you.
Yeah, so basically you just make the profile in the SCAD, and then you can import the profile into like SolidWorks or Fusion 360 or whatever. And then from there you can like design your own pulley and then maybe 3D print it if you want to.
Good question. When you 3D printing, I know you guys have a lot of capability. How well do they last on your material? I know for our team, for the normal material, we have our 3D printer just like you do. But for the high strength, high stress material, we actually reach out to Singularity because they have access to the commercial printer. So for your printing, 3D printing, over time, do you see much stress on the pulley? Or how well the pulley perform over time?
Yeah, so we use a Prusa printer in PETG, and yeah, we've been using them on our chassis, and they've been holding up pretty well. So they're part of the driving between transferring the torque between the motors to the chassis wheels, and we haven't had any problem with them at all. They've been working out great. So
what material do you print those the pulley wheels out of?
Yeah, so we use PETG. Yeah, just PETG.
Just to add a little bit to that, there's a property of different printing materials called the what is it? The elastic what is it? I can't remember the name of the property. It's basically like when you apply force to something, how much it bends before it permanently deforms.
Plastic
right?
deformation, right?
So if you're printing in PLA, what you're going to find is over time, things that are round will become eccentric because PLA does not have a good plastic memory, right? So if you're using PLA for high torque or things that are going to experience a lot of stress, they will deform over time because once they deform a little bit, they never rebound. They don't come back. Whereas materials like ABS and PETG have a very high plastic memory, so they can deform quite a bit and rebound and return to their shape. So they will last a lot longer. So even though PLA is a little bit stronger than those materials in terms of like its impact force, over time the PLA will begin to become elliptical.
I also want to add, like, so we were stating earlier that a good number for the number of teeth on a pulley wheel is about 24. It's a good balance between having 12 teeth of engagement and also being relatively small. And so like the pulley wheels are a bit different than, like, for example, if you're using gears, right? There's only like a few teeth that are engaging, right? So there's not, like, the material has to be very strong. But on a pulley wheel, there's like half of the, almost, if you're using a 1-to-1 ratio, it's half of the wheel that's engaging. So the material doesn't have to be as strong as, say, a gear.
Yeah, the stress is spread out over the entire pulley wheel.
Any more questions?
Well, there's a question in the chat. Gobilda sells pulley wheels that are compatible with their own belts. Is there an advantage to using 3D printed pulleys over that? I think it's just cheaper for us to do that. And I don't think there's any, we haven't noticed any drop in performance between the metal pulley belts and the 3D printed ones. So, and it's also more configurable because we can just set the number of teeth we want and the size and just print it ourselves, and we'll get it within, I don't know, an hour or two. But if you have to order it, you have to wait. So it's just those factors there that are different. I don't think it's anything that has to do with performance that you would be giving up if you did 3D printed belts, or I mean pulley wheels.
Could one of you talk a little bit about the design process for incorporating pulleys? Because it's a little bit different than with chains, whereas with pulleys you have to know your center distance and kind of know what parts are available and design to the parts that are available.
Nico, you want to talk about that?
Yeah, so basically you just have to, unless you want to use some sort of tensioning system, which we can go back to the slides if you would like to see that again, then yeah, you mainly want to understand, like, generally what I do when I'm designing is I take a rough estimate of about where I want the pulley wheels and pulley length to be. And I enter some of that information just to see what available belts are around that length.
You
just know,
PSI, right?
Yeah, I use the SDPSI designer, center distance designer, and an input like which pulley belts I want to use and what size belt I think I'll need in the center distance. And that allows me to see like what belt options are around there. And so if I need to make a slight tweak to the distance that I thought I originally wanted, then I already know which options are available. So you want to kind of look ahead and see what available options you have before you start designing and fixating your design on something that is not going to be available or is going to cost you a lot of money.
One other thing that I'll mention is that the HTD standard is available from, what's that? The HTD standard is available from a lot of different vendors. So I believe GoBuilda sells HTD 5mm belts. I'm pretty sure that Andy Mark carries HTD 5mm belts, as well as SDP SI. And if you do a search for HTD 5mm belts, you'll find a whole lot of suppliers that also carry that standard. So it's a really easy belt to find versus the GT2 standard. They're very similar in terms of their properties, but the HTD standard is just available from a lot more places.
Because it's an older standard, and the GT2 is kind of an update to the HTD standard. Nico, do you want to stop screen sharing so we can see everyone?
Yeah, that's what I was about to do.
So I have a quick question. You were talking about the lead time for purchasing belts. When you're designing, do you just have a bunch of common sizes that you think you might want to use, on hand, or do you actually, design something and then go and order?
Yeah, we do a lot of, at least this year, we're doing a lot of CAD beforehand. So yeah, we figure out all the center distances in CAD and check to make sure that on SDPSI that they're the correct distance that's available and not going to cost us a lot of money if there's that little asterisk. And then once we're done designing, yeah, we order all the belts right after. So we don't just have a bunch of belts lying around. Now that we're using pulley belts a lot more, we do have a few options that we already have for like the next years. But yeah,
Those are just mostly spares though that we've kind of ordered just in case it breaks or something like that.
Yeah, that's another thing. We usually order one spare. So if we need like let's say 2 belts of one size, right? We order 3 just in case one breaks.
You guys should mention also like your first year experience with belts, because you used some belts in your robot the first year, and in that case it was a little different because you just kind of had some belts.
Yeah, that time we had a kit of parts and they just came with belts, and it was kind of like a last minute addition to our robot, and it wasn't really planned out that well. Like we didn't do any of this center distance design or anything. We kind of just pulled the pulley wheels apart until the belt was taut at what we thought was about right. So that was our first year of using belts 2 years ago. So yeah, now we're definitely a lot more pre-planning involved.
This is the picture of our first year's pulley wheels and belts. These aren't either the HTD or GT2. These are just some pulley belts we had laying around from the kit. Right here.
So if you were gonna get like 2 pulley wheels and two belts, one spare, then like one they were gonna use, how much would that cost?
So here I can go back to the SDPSI website.
It depends a lot on the length of the belt and like whether it's double-sided or not.
Mm-hmm.
So yeah,
I can, hold on. So the pulley wheels, if you 3D print them, they're very cheap, like probably less than $1. So here you can see, if I go, this is the cost for a 200 or 104 tooth pulley belt if you order 1 through 9 of them. And as you order more, you get less cheap, less expensive, but obviously we're not going to order that many. So let's say I go to double-sided. This is going to be more expensive because they're less available and less commonly used, so it'll be more expensive.
Speaking of double-sided, what would be a situation that you would use a double-sided belt?
So let's say you're using the external tensioner, like what is shown right down here. Let's say you're using this tensioner here, right? You want to have the outside with teeth as well, so that you can put your pulley wheel on those teeth and it runs along those teeth as well. That's one example of an application there.
Say,
Okay.
or say you wanted to use that tensioner as a drive wheel to drive another mechanism.
Right.
Okay.
You can also use take advantage of the outside, like the double-sidedness. Use one side for actually like driving the pulley belt, but you can also use the other side as like, I don't know, like a conveyor or something, as like something to not just transfer power, but like manipulate something if you wanted to.
Just to comment on cost, it looks like most of our belts cost between $6 and $15 this year.
Here's an example of the cost of a pulley wheel that you might want to order. $13. Then you need 2 of them, so. So I change that to 48.
Question. On the pulley wheel, do you ever adjust the diameter to pulley wheel so you don't have to worry about the tensioner, or will that work?
Yes, that you can adjust, like if you want the tension a little bit more, you can like add a tooth, for example.
Mm-hmm.
It is a little bit, I would say, a bit difficult to do that because you would have to order a new pulley wheel, right? Or you would have to 3D print a new one.
I mean, yeah, I'm talking in your case, your team do a lot of your own printing, right? Obviously, it takes into a little bit more calculation or precision, but I thought that might be an option, especially for the team that, let's say that you go build a part, a Patrick and all that, that may be a good compromise, right? Because a lot of those holes are pre-drilled already, and a lot of times they don't fit perfectly.
Yeah.
I think that might be one option.
Yeah, in our case, you're asking about our team specifically. We don't usually tension at all because we use CAD and we order the right belt for the right center distance, so we don't have to tension it at all, right?
Yeah.
But in those other applications where you're using maybe not using CAD or not using the right belt for that center distance, you will have to tension. We don't. We've never tensioned it by adding a tooth to the pulley wheel. We just usually have tensioned by adding an internal tensioner.
And just to add to that, last year, one of their belt mechanisms used those extruded rails,
Mm-hmm.
so that they could mount the wheels on those rails and just slide them back and forth. So that way they didn't have to have a predetermined length. They just slid it along the rail until it was tight and then tightened it down, which was, I thought, a really great design.
When you say extruded rail, do you just mean like X rail or go rail?
Yeah, okay. Just standard extrusion. And I'll show you, here's an example of, let me share screen real quick. So this is GoBuilder's Beeline chassis kit. We're not ordering this, but this is an example of an external tensioner. It's kind of hard to see here, but you can see they've got a standoff right here with a little wheel on it. because their go build those hole pattern isn't necessarily, like most of the hole pattern isn't compatible with the 2.5 millimeter increments of HGD5 belts. And so in most cases, they have to use this little standoff with the tensioner. But yeah, this is just a great example of how you can tension a belt easily, even on standard like channel, like inside a standard C channel.
You can also change the diameter of that wheel, that tensioning wheel, to add or remove tension without changing the hole pattern.
Yep.
We have 3 minutes left, and then Victor's going to close the room. So any final questions?
I would like to say thank you very much for your team. My team learned a lot from your team, and you guys are awesome. I like the presentation you guys put together. A lot of thought put in there. Great job.
Thank you. Glad it was helpful.
Just to mention, you can contact us right here if you'd like to reach out to us with any more questions.